Hello, this is Nitin Dahad with Times. I'm here in Shenzhen in China, and I'm pleased to say I've got my guest today is Alan Wu, who's the founder of a company called CoreLab, but it needs no introduction. He's got a long history here, and he was also previously with ARM. Alan, hello, how are you?
Great. How are you?
I'm fine, thank you. Thanks for coming and joining me. So tell me a little bit about what you're doing, CoreLab. We spoke maybe a few months ago, but I think I just want to get a feel for where you are. What's your whole philosophy here?
Yes, at CoreLab, we're trying to build a open architecture ASIC platform that we're primarily targeting robotics-related AI compute. So if you look at today in the marketplace, some sort of a robotics device in the end is probably the biggest terminal market, smart terminal market for sort of AI compute. And yet, we know that as OS, the large language model is evolving. It's not quite all the way there yet. In robotics, whether it's a VLA or end-to-end, the whole software OS is evolving. And computing architecture, how many TOPS you need, do you do GPU, do you do ASIC? It's still evolving. And so when we look at this, we realize that for every generation of compute, when there's exponential growth of computing needs, in the end, there's always new computing architecture, right? Logically, for AI, we need that. But how do we solve that? We believe that RISC-V offers a good baseline where we can create multiple processors that's customized to customer needs, and these processors can become computing platform to address different kind of robotics compute needs.
Now, I think I've heard this story many times before about RISC-V, and what I think I've understood from talking to you is it's not just about RISC-V, it's about enabling that heterogeneous platform that allows experimentation, whatever you're using within that architecture. Is that right?
That's correct. And I think that it's for the first time in the computing history, right? Now you can mix and match, i.e., previously, the CPU is from, let's say, ARM or x86.
Yes.
And the GPU is from NVIDIA or somebody else. And DSP is yet from another different player.
You're putting blocks in place and putting lots of connections which you don't necessarily need.
Yeah, and you can't really share the underlying software and all that stuff.
Yeah.
And with RISC-V, finally, we have a way of bringing all that creativity together. Yet we share the same underlying sort of a pipeline software. So we can now actually create sort of a heterogeneous compute at a much lower cost and much easier, much better ease of use. And that's what they're trying to do.
Now, just to give an example, because I think a concrete example, you said you launched earlier this year, Atlantis, your platform, first platform targeting robotics using the Tenstorrent core as well.
Yes.
Just give me an idea of what that does and how it's evolving and where you're seeing it go.
Sure. I use Atlantis, for example, right?
Yes.
And right now, the main processor, we're using a 20 spec in big core from Tenstorrent.
Okay.
And for all the rest of security island, security control embedded stuff, we're using a processor from CoreLab.
Okay.
That we actually customized for Tenstorrent. And for power management, we have yet another core that we have RISC-V based and we customize for Tenstorrent. So now we can quickly put together multiple cores on the same platform. And then on the AI side, we have a PCI slot where Tenstorrent can plug in their RISC-V based accelerator card onto it. Now, in the future, obviously, we can offer a customer the entire SoC based on that. The reason we do that is that we believe that with RISC-V, we can actually allow sort of pioneers to explore different things, right? ARM is a great company, NVIDIA is a great company, but for pioneers who want to do something different, there's really right now very hard, very expensive to do this.
We talked about the expense.
Yeah.
I mean, specifically with Atlantis, I think you said you're expecting to tape out early next year or mid next year?
Yes, we expect to tape out around April next year.
Okay.
And so we should have all the developed boards available somewhere in August, right? And So as I mentioned earlier, so you look at today, right? If you want to do anything in, let's say, this is really basically 8 specking 20 compute cores, and
Right.
with full stack PCIe. So if you want to do this level of high compute, I mean, you're looking at just an IP cost today is like 100 million or above, right? If you want to do custom processor, you got to pay, God knows how much for architecture license.
Okay, and then so you've got a roadmap, I think, of several platforms, and I think one of the things you said is, once it's out there, people can have more power, less power, more performance, etc. So there's a roadmap of cores as well as the ability to utilize those existing platforms.
Yeah, I mean, our goal is to allow pioneers to turn their imagination into the actual architecture. Right. So it's the first time you allow somebody to actually customize the processor, customize the chip, and customize the computing platform, right? And that level of ability to go all the way down to the deep computing level. In the future, we hope that RISC-V would afford an ecosystem where many players can contribute different blocks of the pipeline, the accelerators. So if I were any user, I'm able to mix match the best processor architecture for my compute task.
Now, one of the things I think I've understood from you, you've had quite a sort of collaboration with Jim Keller and Tenstorrent right. on this, and you share quite strongly similar views, don't you, on this openness?
Yeah, I mean, I think that's actually the sort of one reason we started this, is that if you look at my experience in ARM, the part I really enjoy, I mean, ARM is a great company. It's the first time in the hardware community you have fairly open ecosystem where customer can create whatever they want in terms of product based on a set of platforms, which is ARM-based. And initially, for every platform we worked on, it turned out to be sort of, I wouldn't say mavericks, I would say pioneers, right? Yeah. Some would call them mavericks, who are doing things at time looks pretty iffy,
yeah,
right? And yet they look at every wave of compute technology. It's these pioneers in the end actually change our industry. I really like the fact that at ARM, we worked with hundreds of companies and dozens of pioneers who actually made it big and made a huge difference. And I think with RISC-V, I hope to do the same thing, right? If you wanted the standard product, ARM is great. If you want to do custom compute, you want to do something different, and we offer something that's actually customized for you.
Okay, I'm going to try and close it because I know you're a busy man. But in terms of the naysayers, I mean, there's always been people talking about how, oh yeah, RISC-V, no, yep. It's a little toy thing or whatever. Just for experimentation, no tool chains. What's your proposition that says, well, we're going to succeed?
Yeah. So number one, we're already seeing, whether it be Jim, a number of other companies, you already see very high performance CPU pipeline out there.
Yeah.
That's as good as ARM's or even better. Number two, there are many different components that's actually available in the community. It's right now, it's just hard to use. It's like Linux early days. Right? Average user doesn't know how to take Linux and actually make it into a desktop operating system, right? And yet, if you look at Android, it takes Linux, turn it into something that anybody can use. What do we want to do is to actually build an Android platform for compute right. in the RISC-V world, right, for the hardware.
So I think what you told me earlier is, trying to make chip design, but more than chip design, compute more affordable.
Yeah, exactly. Make it really affordable. In the end, if I want to do a robotics design, instead, I have to pay a couple $100 million to start. You know what? I take the platform, I pay 1/3 or 1/4 of the price, and I actually have a chip the way I want it, and work with the OS or whatever VLA or model that I'm using. Right? That's the goal.
Well, I wasn't trying to do your sales pitch, but Alan, I think it's a very interesting journey you're on. Hope you succeed. Thank you.
Thank you. Thank you for your time.